This video goes through the Chapter 10B practice test on Schoology. Feel free to skip answers until you see the one that you are interested in finding. So the first question, question 1, talks about classifying each of the arcs just as minor, major, or semicircles. Okay, anything that has 2 letters is going to be the minor arcs. Okay, because if it has 2 letters or less, then it has to be, it's telling you that it has to be less than 180 degrees. Anything with 3 letters or more is telling you a direction of the circle that you're going. So all the 2 letters, you can say, are minor arcs. Okay, the 3-letter ones are either major or semicircles. Semicircles are the ones that are exactly half of the circle. So go in the order that it says, C, F, D. Okay, that goes for more than half the circle, so that's called a major arc. F, D, B, go in that exact direction. F, D, B, that's more than half the circle. So again, that's a major arc. C, B, F is exactly half the circle. C, B, F. That's called a semi. Okay, and then E, F, B is the same thing. E, F, B in that order, in that direction, is exactly half the circle, which makes it a semicircle. 3 letters or more, it's either semicircle or major. Semicircles are exactly 180 degrees, half the circle. Okay, similar question for finding the angle measures here. Okay, the measure of arc TC, that would be this arc, which is, if I know that there's 128 degrees in the center, I know that there's 128 degrees on the outside. So that's what this one is. TBD, okay, that's this distance here, TBD, that's half the circle. Okay, it's cut off by a diameter. So that red solid arc is half the circle, which means it's 180. BTC, okay, that would be from here to here, okay? If this is 90 in the center, I know that this is 90. So what this one is 90 plus 128. Okay, if the 2 arcs are adjacent, they're right next to each other and they don't overlap, what you do is add the 2 arcs together, the 2 angle measures. So that's going to be 218 degrees. Okay. Angle CPD, that's in the center of the circle now. Okay, so angle CPD, that's this one right here. Okay, well, it's a linear pair with this angle, this 128. So CPD, the way that we would get it is 180 minus 128. Okay, which is going to be 52 degrees. So I know that this is 52, which means I know that this is 52. Okay, angle CPB, okay, is going to be a similar situation. CPB, well, I know that there's a 90 on this side, which means there's a 90 on this side. So if I want this entire angle, what I need to do is I need to add 90 plus 52 and get 142. And then arc TCB, that's this one. There's 2 ways you can think about this one. You could add up all these pieces. So you have a 128, a 52, and a 90. You could add those up. Or this little piece right here is 90, and the black plus the green has to equal 360. So you could just do 360 minus 90, whatever you think is easier, but 270 degrees for that. And last one is CD. We already have that one marked. So CD is right here. Okay, so that's 52 degrees. If it's 52 as the central angle, it's 52 as the arc on the outside. All right, moving on. Tires on Mr. Monahan's car have an 18-inch diameter. The Gravedigger monster truck has tires with a 66-inch diameter. To the nearest inch, how much farther does Gravedigger travel in 1 revolution than Monahan's car? So if the wheels spin once. So if the wheels spin once, you're going to travel whatever the circumference is. And the circumference is just going to be equal to pi times the diameter. So for Gravedigger, The circumference is just pi times diameter, which is 66 pi. For Monahan's car, not going to tell you what kind I drive, is 18 pi times diameter. What we need to do, how much further, all I need to do is subtract these. So for my answer here, I need to take 66 pi minus 18 pi. You got to be careful with this. This is how that works. The pi's don't cancel here. We end up with 48 pi. And then it says to the nearest inch in terms of rounding. So what we would do is just do 48 pi. So you don't want to use 3.14. Use the pi button on your calculator so you get the exact right answer. So this is 150.8, but to the nearest inch, that's 151. So that's what you should be putting in here. To the nearest inch, that's 151 inches. Moving on to the next problem. Question 4, okay, find the circumference of the circle and then find the arc length. Those are the two things that we're going to look to do. So they're interested in, number one, just the circumference, and they already have the pi as part of our answer, so you're not going to type in that part. But for circumference, you're just doing pi times diameter or 2 pi r. We're going to use pi times diameter for this one since they gave us the diameter. So the diameter is 6. That means the circumference is 6 pi. So you just put a 6 into the blank. And then it says find the length of the darkened arc. Okay, so the length of the darkened arc, that's this direction here. Let me show you. So they're talking about this arc here, the part that's shaded in. I know that's kind of hard to see, so that could be your mistake. If this piece is 120, that means that this entire thing is 240. So what you're doing for arc length is a fraction out of 360. How many degrees out of 360 times that circumference? Your answer to part 1. Okay, so this is equal to 2/3 of 6 pi, and 2/3 of 6 is 4, so this is 4 pi. So we're putting in the 4, the pi's already in the calculator, or in the Schoology, I should say. Okay, so in terms of pi, we just have 4 pi. Same question, different picture. Finding the circumference first. You just have to know if you have a radius or a diameter. This one is a radius, so now we have to double it. 2 pi times the radius, which is 5. So in terms of pi, we have 10 pi inches for our circumference, and then they want this, the length of this arc. The first thing you want to get is the amount of degrees that arc has. And the way we're going to do that, I'm going to make it red. The way we're going to do that is 360 minus 225. It's 225 the other direction around the circle. So this one is 135. Okay, 135 degrees. So what we end up with is 135 over 360 times that circumference, times the length all the way around. So as a fraction, this is like 3/8 of 10 pi. So sometimes you end up with a decimal, but that's okay. This is equal to 3.75 times pi. So 3.75 is what you type in the blank. The pi is already there. Okay, moving on. I think there's one more like that. And there is. So the circumference of the circle, again, the whole thing. This is a diameter this time, so we're just using pi times diameter. So 15 pi is that answer. Then what they want is this arc, okay, which is 180 minus 45. This piece is 45, and that makes a semicircle together, which means that that's what we're looking for in terms of the arc. So the arc itself is 135 degrees, okay? And then that's the same fraction we just had, and that's okay, no big deal. So what happens there is we're taking 135 out of 360 times that circumference, our answer to the first part. So again, this is 3 out of 8. Times 15 pi. So another decimal, and that's fine. Not a big deal, but 5.625 times pi, that's how many meters our arc would be. Okay. Then we move on to sector area. So finding the area of the slice of pizza. Find the area of the shaded segment or sector. This one says leave your answer in terms of pi. I think some of them, or one of those, will end up switching. So what we have is we need the amount of degrees over 360 times pi r squared. So we need to know how many degrees, and we need to know what the radius is. Those are the two things we need to know for sector problems. If we have 144 on the inside as a central angle, we have 144 on the outside. So what we have here is 144 3/60ths times pi times the radius squared. Excuse me. Be really careful that you don't use a diameter in that step. So 144 out of 360, that simplifies down nicely all the way to 2/5. 4 squared is 16, so this is 2/5 of 16 pi, and don't be worried if your answers end up being decimals in front of the pi. 2/5 of 16 is 6.4. So 6.4 times pi is that answer, square feet. Next, this one again says in terms of pi. So this is the same picture we had before, but we have a diameter of 15. We need x over 360 times pi r squared. So x degrees. How many degrees out of 360? So the part that we want is this part. We want to know the area of this. This has 135 degrees like we talked about in the previous one. Okay, those two numbers, 135 and 45, need to make 180 since it's half the circle. So we have 135 over 360. Okay, this is where you have to be really careful. The radius is half of the diameter. So you don't use 15 right there, use 7.5. Okay, again, we've said this a few times now, but this is 3/8. Times, we can do the 7.5 squared and get 56.25. I did not put the pi in the calculator at all, so that's just there at the end. 3/8 of that is going to be about 21.1. So this is 21.1 pi. And that's in square meters. Okay, so 3/8 of that, 56.25. Last one for sector. This one says nearest tenth, so I am going to put the pi in, and I have a note here too. Note, this one is not in terms of pi. So again, we've seen this picture already. And we're using 135 yet again, but this has 135 degrees. We want the area of this slice of pizza. 5 is a radius. So we're able to go right to the formula, 135 over 360 times pi times 5 squared. Okay, this is 3/8. We're just getting that a lot for the practice test, just a coincidence. It's because we're reusing some pictures. So you do 3/8 of 5 squared, which is 25. So 3/8 of 25 is going to be 9.375 pi square inches. And I think I put a couple, oops, and this is not in terms of pi, like I said. So what we need to do is do times pi. So that's my mistake. I almost forgot. So this is going to be 29.45, which rounds to the nearest tenth, 29.5 square inches. So that one just said in terms of nearest tenth, so I had to multiply by pi. So that's my rounded answer. The one in the box is the exact answer. The one in the circle is the approximation based on how they wanted us to round. All right, number 10. The picture is not that big, but what's going on here is we're looking at these segments and finding the probability that those segments are landed on if we pick a random spot. So, for example, segment FH, that's this segment. It has a length of 14 minus 10, which is 4. Okay, so segment FH, we have 4 divided by, okay, what we want is the entire segment on the bottom. So the entire segment here has a length of 20. It's 20 minus 0. So that's the bottom of our fractions. Okay, so what we have is 4 over 20. You can't type that in. They want nearest thousandth. So that would be 3 decimal places. But 4 divided by 20 is just 0.2. So you could just write it as 0.2, which is 20%. Okay, segment CH is also something over 20, but between C and H, we have 14 minus 4, so 14 minus 4 is 10. So this is 0.5. Okay, again, it says 3 decimal places, but you really don't need them. If you wanted to do 3 decimal places, you could do 0, 0. Moving on. Probability given a picture. You got to get the shaded area and the total area and divide those two. A point in the figure is chosen at random. Find the probability it's in the shaded region. The figures may not be drawn to scale. So the total area, okay, we can start with the shaded. That's actually fine. So the shaded area is just a rectangle, and that's base times height, with a base of 11 and a height of 7.1. So we're just going to multiply those two. We get 78.1. And that's going to be like the top of our fraction. So this is an important number. Then we want to get the total area. Okay, the total thing, the whole thing is a circle. So that's pi r squared. So as long as we know r, we are good to go. R is going to be this 9 right here. That's the radius. So pi times 9 squared, okay, which is 81 pi. And I'm not going to put that in the calculator just yet. I'm going to do that all in the last step so I don't have any rounding issues. So the probability that we hit the shaded part is the area of the shaded rectangle divided by the area of the whole thing. Okay, be careful when you type this in. Make sure you get the same thing as me. If you don't get the same thing as me, then you're probably not using parentheses on the bottom. But this is going to come out to 0.3069, and they want to round to 3 decimal places. So that would be 0.307. So you multiply base times height to get the rectangle, pi times r squared to get the circle, and then it's just rectangle divided by circle, shaded divided by total. Okay, next one. This one, you don't have a radius, but you don't really need it. Okay, we have 104 degrees shaded, and we know that there's 360 degrees in a circle. So this is all I need. 104 divided by 360. Okay, that's going to give you 0.28 repeating. Okay, to that third decimal place that's right here, so that's 0.289. The amount of degrees over 360. That's all you need for a circle. Probability. For this one, we have a triangle on the inside, and we have a rectangle as the whole thing. So for this one, what we want to be able to do is get the total area. And that's just base times height. It's a rectangle. So that would be 10 times 6. So the whole thing is 60. That's an important number. The shaded part, okay, is 1/2 base times height, 1/2 times 4 times 6. Okay, and that's 12. That's an important number. What we need to get the area probability that we hit the shaded triangle, that would be 12 over 60, which should just be 20%. Okay, that'll do it for probability. Okay, these next two are from 10.5 using 1/2 ASN. as our formula. So regular polygon formula, 1/2 ASN. So what we want to look at is, do we have each of those things? Okay, if it's a pentagon, we know that n is 5. This distance right here is called A. So that's 9.2. What we don't know is S. So we got to figure out S. Okay, so what we like to look at is this triangle right here. What we need is this angle. Okay, we can get the entire angle by doing 360 divided by, that's just a little bit too much stuff in here. That's fine. We can get the entire angle, okay, by doing 360 divided by 5. That's 72 degrees. However, the A, called the apothem, cuts that in half. So I'm really going to put a 36 in here. Okay, and I'm going to use this right triangle to figure out what S is. I want to figure out this distance, S. Well, what I can find right away is just half of it, this X right here. Okay, so in this triangle, I'm using SOHCAHTOA. X is called the opposite side. 9.2 is called the adjacent side. And when I use SOHCAHTOA, that leads me to select tangent, okay, because I have the opposite side and the adjacent side. I don't need this hypotenuse for anything. Okay, so what happens is I go to tangent of 36. That equals x over 9.2, opposite over adjacent. When the number is on the bottom, you multiply both sides by that number. So 9.2 tangent of 36 is equal to x. And I'm going to round a little bit here so I can show you the next part. This is equal to 6.68. But that's not what S is, okay? That's only this much, 6.68. This part is also 6.68. So what we need to do is double that, and we end up with 13.36 when we do that. So that's going to be a little bit rounded. So we want to do times 2. That's going to give us S. So this was really 684. So when you double that, you get 13.368. So I'm just going to put 13.37 in this step. Okay. Once you have all three of these things, it's just calculator work. 1/2 times 9.2 times 13.37 times 5. Okay. And if you do that, I'm doing it right now. I came up with 307.51. They said nearest whole number, so that's going to be 308 square feet. Nearest whole number. Next, we have a octagon, and looking at doing the same thing. So the octagon right here is we're given S, and we need to find A. Okay, so we know that A is what we want, S is 13.4, N is 8. Okay, and again, we're looking at this triangle right here. Okay, we know that this is 13.4, but really what's happening when we draw A in there is it's getting cut in half, so we're going to use 6.7 right here. This angle, I have 360 divided by 8, which is 45, but that makes this angle right here 22.5 degrees. Okay, again, it's tangent. This is the opposite side. A is the adjacent side. So we're going to use tangent of 22.5 equal to opposite over adjacent, so 6.7 over A, which is what we're trying to find. When the letter is on the bottom, you multiply both sides by A, and then you divide both sides by tangent. It ends up looking like this. This is the exact answer for what the length of the apothem is. If you do that in the calculator, you get 16.1752. It's just showing you different ways to round. It's ideal to just punch all of this stuff in one long calculator step, which is essentially what I'm doing here. You just can't see my calculator. We're going to do 1/2 times that we just found, times 13.4, and then times 8. Okay, if you do that, looks like you get like 866.99 to the nearest whole number. That would be 867 square meters. Next, these have a special formula. So I have both of the triangle ones here on the same page. We have 1/2. What you do with these is BC times the sine of A. These are triangles where you don't know the height. So what we have is side, another side, and the angle in between for these. It doesn't matter if B is 15 or 8. One of the sides is B, one of the sides is C. The angle is A. So all we're doing is 1/2 times 15 times 8 times sine of 46. This time the way they want us to round is going to be to the nearest 10th. So we do 1/2 times 15 times 8 times sine of 46. And that's all just calculator work. That's 43.16, which is 43.2 square centimeters. On the test, they're going to ask you for units a lot. Okay, same formula for number 17. Number 17, it doesn't matter what's B and what's C. 1/2 times 12 times 11 times sine of 82. Okay, and then again, it's just calculator work from there. So 1/2 times 12 times 11 times sine of 82. So 65.36, and that's going to round up to 65.4, and we're in square millimeters. So those have their own formula. 1/2 base times height is great, but if you don't have the height, then you need to use this alternate formula when you have two sides and the angle in between. Okay, and then I think we have 18 and 19, and that is it. So yeah, perfect. So 18 and 19, they're finding something called a segment of the circle. That's this part right here. Okay, the way that we do that is we find the area of the entire slice of pie, and then we take out the triangle. Okay, so for this one, we know that this is a 90 right here, so that means this is 90 degrees. So the area of what we're going to do for the steps is sector minus triangle. So we need the sector first, okay, which is 90 over 360 times the area of the circle, pi times the radius looks like 4 right there, squared. So the sector is 1/4 of 16 pi, which is 4 pi. Not our answer, but important. Okay, area of the triangle, I want to take this triangle away from that. If I take that triangle out, then I'm able to get just the blue colored in part. For now, we can just use 1/2 base times height, not the other formula we were just doing, because we have a 90-degree angle in there, which means we know 4 is the base and the height. It's a right triangle. It's a right isosceles triangle. So this is, again, 1/2 of 4 times 4, which is 1/2 of 16, so we are at 8. Okay, so the exact answer for the segment, which is what we want, the colored in part, this part right here, okay, it's 4 pi, the whole slice of pizza, minus 8, which is the triangle, and that gives you kind of just the crust. Okay, we want to round to the nearest tenth, so we're going to type it all in one step, 4 pi minus 8, and this gives you 4.57 to the nearest tenth, that's 4.6 square meters. And the last one, it's a little bit different because we don't have a 90-degree angle for what we're looking at. So we're going to do the same thing, sector minus triangle. So here's the sector step. We have to figure out how many degrees that is. It looks like R is going to be 6 for this problem. We have these two pieces as being 30 here and here, which means since those three arcs need to make 180, we have 180 minus 30, so this is 120 degrees, which means this is 120 degrees. Okay, this is 6 and this is 6. So the area of that slice of pizza is, so for the sector, we have 120 out of 360 times pi r squared, pi times 6 squared. That's 1/3 of 36 pi, which means that the sector, the slice of pizza, has an area of 12 pi. Important, but not our answer. Then we want to take this triangle out. Okay, this is a triangle that we can't use 1/2 base times height for because of that 120. So this is when we use that other formula, 1/2 BC sine of A. B and C are both 6. So we're doing 1/2 times 6 times 6 times sine of 120, which is to the nearest 10th, going to be 15 point, well actually I'm going to leave that exact right now, and then I'm going to subtract them at the end. So what I'm going to do is keep that the same, just to show you the right way to round this. The segment is just subtracting those two. So to keep it exact, we would want to just do it all at once. 12 pi minus 1/2 times 6 times 6 times sine of 120. I didn't do it in the last one because our triangle wasn't a decimal. This one would be. So if you type it in all in one step, you end up with 22.1 if you go to the nearest 10th. So 22.1, and this time we're in square inches. So that's how you get a segment. It's kind of like just the crust of the pizza. And that should be it for this practice test. Thanks for watching. Good luck on your test.